Drive down Loudoun County Parkway in Ashburn, Virginia, and you will see nothing but concrete. Massive, windowless, brutalist squares stretching for miles across former farmland. There are no corporate logos flashing on the facades. There are no massive glass atriums. The parking lots are mostly empty, save for a few security vehicles and maintenance trucks. It looks like a graveyard of modern industry. But underneath the asphalt, encased in steel conduits, lie millions of miles of yellow fiber-optic glass. This quiet stretch of Virginia is known as Data Center Alley. It processes an estimated 70% of the world's daily internet traffic. Every email you send, every stock trade executed by a Wall Street algorithm, every movie streamed to a television in Tokyo, chances are it physically travels through Ashburn. We have been sold a specific story about the digital economy. We call it the cloud. The terminology implies something ethereal, floating, everywhere and nowhere at once. It suggests a decentralized utopia where software transcends physical borders. The reality is exactly the opposite. The internet is a heavy, industrial, intensely physical machine. And more importantly, it is highly centralized. The decentralized web is a myth. The digital economy is, at its core, a commercial real estate business. The companies that own these concrete boxes do not write software. They do not build search engines. They do not manufacture microchips. They are simply digital landlords. And inside these buildings lies a specific, highly secured area known as the Meet Me Room. It is here, among humming cooling fans and rows of black steel cages, that the digital economy is actually routed. The entire system hinges on a mechanism so simple it seems absurd. A physical fiber-optic cord linking one server to another. A piece of plastic and glass that costs about $30 to manufacture. But that single cable is the foundation of a hidden toll road system, generating billions in recurring revenue. To understand who truly controls the digital economy, you have to stop looking at the software. You have to look at the floor space.
To see how the internet became a real estate monopoly, you have to look at what it was originally supposed to be. In the 1960s, the U.S. Department of Defense funded ARPANET. The architectural mandate was strict. The network had to survive a nuclear strike. If Soviet missiles wiped out a communications hub in New York, the data had to instantly reroute through Chicago or Atlanta. The system was designed to be inherently decentralized. Every node was equal. No single physical point of failure could bring the network down. For decades, this philosophy governed the growth of the web. But as the internet commercialized in the 1990s, a new physical reality emerged. Data is just light pulsing through glass. It travels fast, but it is still bound by the laws of physics. It takes roughly 14 milliseconds for a photon to travel from New York to Chicago. In human terms, that is nothing. In computational terms, it is an eternity. As dial-up gave way to broadband and text gave way to video, latency became the enemy. If an internet service provider in Los Angeles wanted to load a website hosted on a server in Boston, the data had to traverse thousands of miles, bouncing through a dozen different routers. Each bounce added milliseconds. Each bounce degraded the signal. The solution was peering. Instead of routing traffic across the country, different networks decided to physically connect their equipment in a shared location. If America Online and an early telecom provider placed their routers in the same room, they could just plug a wire directly between them. They called these locations network access points. The most famous was Mar East. It was located in a parking garage in Tysons Corner, Virginia, chosen simply because it was close to the telecommunications infrastructure of Washington, D.C. By the mid-1990s, half of the world's internet traffic was flowing through a single, cramped room in a Virginia parking garage. The heat was unbearable. Technicians would literally kick cables out of the way. The decentralized military network had accidentally created a massive physical bottleneck. This was the historical blind spot. Tech visionaries were predicting the death of geography. They argued that the internet would make location irrelevant, but the engineers running the cables knew the opposite was true. Speed required proximity. If you wanted to survive in the digital economy, your server had to physically sit next to everyone else's server. Geography was not dead. It was condensing into a few hyper-dense zip codes. As the dot-com bubble swelled, the demand for peering locations exploded. Telecom companies tried to build their own hubs, but competitors refused to connect there. AT&T did not want to place its core routing equipment inside a facility owned by Sprint. They needed neutral ground. The market demanded a Switzerland of the internet,
a place where fiercely competitive networks could safely lock their servers in cages and seamlessly hand off traffic. The stage was set for a massive transfer of power. The public infrastructure of the early internet was about to be privatized, enclosed, and monetized by a new breed of company. A company that understood that the real money wasn't in building the network. The real money was in owning the room where the networks had to meet.
In 1998, two facilities managers at Digital Equipment Corporation, Jay Adelson and Al Avery, saw the chaos of MAE East and realized it was unsustainable. The physical infrastructure of the internet was held together by duct tape. They proposed a radical business model. They would build massive, highly secure, climate-controlled data centers. But unlike other companies that use data centers to host their own web services, Adelson and Avery would run a purely neutral facility. They called the company Equinix, a portmanteau of equality, neutrality, and internet exchange. Equinix would not provide internet service. It would not lay long-haul fiber-optic cables across the ocean. It would simply buy cheap land, build a concrete fortress, secure reliable grid power, and lease empty floor space to the networks. The pitch was simple. Move your servers into our building. Your competitors are already here. By physically co-locating, you can plug directly into them, bypassing the congested public internet. This direct connection drops latency to nearly zero. It saves millions in transit costs. The physical architecture of an Equinix facility is designed around a single core concept, the Meet Me room. This is a highly restricted area within the data center. Individual companies lease locked steel cages on the main floor to house their servers, but no company is allowed to run a cable directly from their cage to a competitor's cage. Instead, all cables must route up to the ceiling, travel along yellow overhead trays, and terminate in the central Meet Me room. Equinix controls this room. Equinix technicians are the only ones allowed inside. If Network A wants to connect to Network B, both parties submit a request. An Equinix engineer then takes a short fiber-optic patch cable and physically plugs the two ports together inside the Meet Me room. This is the cross-connect. On paper, the business model looked like traditional commercial real estate. Equinix was a landlord leasing square footage, but the incentives were entirely different. In a traditional office building, a tenant moves out and another moves in. The value of the space remains relatively static. But in a co-location data center, a network effect takes hold. Every new telecom provider that moves into the building makes the building exponentially more valuable to the next telecom provider. If 50 networks are already in Ashburn, the 51st network has no choice but to deploy there too. The gravitational pull of the ecosystem becomes inescapable. Over the next decade, Equinix expanded globally, building identical concrete boxes in London, Tokyo, Frankfurt, and Singapore. They eventually restructured as a real estate investment trust, or REIT. This legal designation, typically reserved for shopping malls and apartment complexes, granted them massive tax advantages. By classifying servers and cables as real estate assets, they shielded their profits. They had convinced Wall Street and the IRS that they were just landlords. But they were landlords of a completely captive market. The executives realized they had built the ultimate toll booth. They had successfully lured the entire digital economy into their concrete boxes. Now it was time to raise the rent. The true genius of the co-location model lies deep within the 10K filings submitted to the Securities and Exchange Commission. When you read the financial statements of data center REITs, a startling disparity emerges. Leasing raw floor space and power provides a steady, predictable return. But the real margin, the staggering windfall that drives the valuation of these companies, comes from interconnection, the cross-connect. Let us trace the economics of this physical mechanism. A standard fiber-optic patch cable costs a data center operator perhaps $30 or $40 to purchase. Installing it takes an engineer about 15 minutes. It is a one-time physical action. But the data center does not sell the cable. It leases the connection. Equinix and its competitors charge a recurring monthly fee for every single cross-connect. That fee ranges from $300 to over $400 a month for one piece of glass. Once plugged in, the cable requires virtually no maintenance. It draws no electricity. It just sits there, flashing light. Yet it generates thousands of dollars a year, in perpetuity. Now, scale that up. A massive data center in Ashburn might house tens of thousands of individual cross-connects. According to their financial disclosures, interconnection revenues often boast gross margins exceeding 90%.
it is nearly pure profit. The data center operators have effectively monetized the space between servers. This pricing power relies entirely on the brutal switching costs of the physical world. Consider the position of a modern enterprise. A high-frequency trading firm in Chicago relies on algorithms that execute stock trades in microseconds. Being physically located in the same data center as the financial exchange's matching engine is not a luxury. It is a life or death requirement. If the trading firm's server is even 1 mile down the road, the added latency will cause their trades to arrive late. They will lose millions. So they pay the rent, and they pay the cross-connect fees. They have no leverage. Or consider a streaming giant like Netflix. To deliver 4K video without buffering, Netflix must cache its content as close to the end user as possible. They cannot stream every episode of a show from a server in California. They must place their servers inside colocation facilities in every major global market, connecting directly to local internet service providers like Comcast or Verizon. If the data center raises the price of the cross-connect by 10%, Netflix cannot simply pack up its servers and move. Rerouting network architecture takes months of planning, millions of dollars in capital expenditure, and risks catastrophic downtime. The data center operators know this. They have trapped the tech giants in concrete. And then the cloud arrived. Companies like Amazon Web Services, Microsoft Azure, and Google Cloud promised to virtualize everything. They built their own massive proprietary data centers. For a moment, it looked as though the neutral colocation providers might be bypassed. But the cloud is just someone else's computer, and enterprise clients still needed a way to physically connect their legacy corporate networks to AWS and Azure. The cloud providers realized they could not bypass Equinix. They had to integrate with it. Amazon and Microsoft established massive network nodes inside neutral data centers.
They created services like AWS Direct Connect, allowing corporations to bypass the public internet and run a dedicated fiber cable straight into Amazon's servers. But where does that physical cable live? Inside the Meet Me room. The data center operator still owns the floorboards, they still own the ceiling trays, and they still charge the monthly toll. The physical gravity of Ashburn became absolute. Today, the power grid in Loudoun County is strained to the breaking point. The local utility, Dominion Energy, has repeatedly warned that the region's transmission lines cannot handle the endless demand for megawatts required to cool these concrete boxes. Yet the data centers keep expanding. They are tearing down office parks to build more windowless monoliths. The bottleneck has solidified. The internet, a technology built to route around damage, cannot route around Ashburn. The real estate landlords managed to execute the greatest structural capture in the history of modern business. They watched the software developers build a multi-trillion-dollar digital economy, and then they quietly bought the land underneath it. Infrastructure is invisible until it is monetized. For 30 years, the public has been enchanted by the interface. We look at the glowing screens, the seamless apps, the instant global communication, and we believe we are living in an era of weightless innovation. We celebrate the software engineers who write the code and the venture capitalists who fund the platforms. But beneath the interface, the old rules of power remain entirely intact. The digital revolution did not eliminate rent-seeking. It merely optimized it. By examining the cross-connect, we strip away the mythology of the cloud. The system is not a diffuse, resilient network hovering in the atmosphere. It is a highly concentrated, incredibly fragile collection of industrial warehouses. The pioneers of the internet dreamed of a public utility that would democratize information. Instead, they built the most efficient toll road in human history. The shift from decentralized public network to centralized private real estate was not an accident. It was the predictable result of physical constraints meeting financial incentives. The landlords of the digital age realized that whoever controls the point of intersection controls the market. You do not need to own the data. You do not need to own the algorithm. You only need to own the $30 piece of glass that allows them to speak to each other. As artificial intelligence accelerates, driving an unprecedented demand for localized compute and massive data transfers, the leverage of the physical layer will only increase. The algorithms will become more sophisticated, the software will become more abstract, but the machines will still run hot. They will still require megawatts